Correct. Correct. अस्सलाम वालेकुम।
जी अस्सलाम वालेकुम, मेरी आवाज आ रही है सबको?
कम से कम मुझे तो आ रही है।
जी आवाज आ रही है? जरा जिस चीज को आवाज नहीं आ रही वो हाथ खड़ा कर दें। मियां साहब आपको आवाज आ रही है मेरी?
आ रही है।
सोहेल किबरिया, आई कांट हियर यू। आप अपना माइक चेक करें प्लीज।
किसको, मुझे कह रहे हो?
नहीं, सोहेल किबरिया सर।
अच्छा,
हेलो।
हाँ जी, अब आ रही है आपकी आवाज, ठीक है, आ रही है।
आज क्लियर है? ठीक है,
जी जी जी, आ रही है।
राइट राइट।
आज 2 बजे का ही टाइम था, लेकिन इस वक्त कोई 50 बंदों ने रजिस्ट्रेशन कराई है, तो अभी 12 लोग ही आए हैं। थोड़ा और वेट कर लेते हैं। लेट इट बी कोई 25 को क्रॉस करें तो फिर हम इंशाल्लाह शुरू करेंगे। तो इस डिले के लिए माजरत। अब आज पता नहीं क्यों नहीं, लोग तो नॉर्मली पहले आ जाते हैं, लेकिन आज इनको देर हो गई है। इस वक्त मेरे पास जो लॉग आ रहा है दैट इज अबाउट 13 पार्टिसिपेंट्स हैं। सो तो 12-13 का और इंतजार कर लेते हैं, देन वी विल स्टार्ट इंशाल्लाह।
साहब आप स्क्रीन शेयरिंग की मुझे परमिशन दें, अभी डिसेबल हुआ हुआ स्क्रीन शेयरिंग।
जी आपको परमिशन है?
अच्छा, यहाँ मैं देख रहा हूँ होस्ट डिसेबल्ड पार्टिसिपेंट स्क्रीन शेयरिंग।
अच्छा, मैं 1 मिनट की, मैं जरा अपने आईटी की बंदी को बुला लेता हूँ। मैं क्या मेरे पास तो ठीक आ रहा है। मैंने नहीं मिल रही स्क्रीन शेयरिंग की परमिशन, नहीं मिल रही। तो कहाँ से होती है? 1 पार्टिसिपेंट लिखा हुआ, इस पे आ रहा है। एडवांस शेयरिंग ऑप्शंस तो नहीं देते। ओनली ऑल पार्टिसिपेंट। देखें जी, अब आ गई है।
मैं देख रहा हूँ जी।
हाँ जी, आ गई है, ठीक है
जी, आप देख सकते हैं, ठीक है।
हाँ जी, अब शेयरिंग खत्म कर दें। जब आपका लेक्चर शुरू होगा फिर आपने शुरू करनी है।
जी जी जी, आई नो।
अगर आप बचना चाह रहे हैं तो जीवन शैली अगर उनको बताना है। जरा वह आपके भी स्क्रीन शेयरिंग आ रही है, जरा इसको थोड़ा सा क्लोज करेंगे सुहेल।
हाँ मैं देख रहा हूँ जी जी।
यार वसीम साहब से लेके ये मास्क छोटा है मेरे लिए, वसीम साहब से लेके। थैंक यू, होगी।
वेलकम। अभी हमें जूम पे हाथ साफ करने पड़ते हैं। मैं अपनी बात कर रहा हूँ, अभी मैं अपनी बात कर रहा हूँ। आई एम नॉट रियली गुड एक्सपर्ट एट जूम एक्सेप्ट डिलीवरिंग।
अच्छा अच्छा अच्छा।
अच्छा ये वैसे ताहिर, मैं अब क्योंकि टाइम है थोड़ी सी बात करना चाहता हूँ। क्या पाकिस्तान इंजीनियरिंग काउंसिल के भी कोई डेलीगेट्स इसमें शामिल होंगे आज?
देखें कि अभी तक तो कोई नहीं आया, तो
अच्छा
तो आ जाएगा वो डेफिनेटली। वो मॉनिटर तो करते हैं ना, तो
अच्छा।
आ जाएगा।
उन्होंने आपको फॉर्मली रिक्वेस्ट की जावेद सलीम कुरैशी साहब या किसी और ने कि हमारे लोगों को भी शामिल किया करें अपने लेक्चर्स में?
सर उनको हम इन्फॉर्म कर देते हैं ना, वो हमारे पे जो
अच्छा
रिस्पॉन्सिबिलिटी लगाई हुई है कि हमने उनको इन्फॉर्म करना है। अब वो आए ना,
ओके।
मर्जी होती है, उनको इन्फॉर्म कर दिया जाता है। उनके ईमेल एड्रेस पे भी इन्फॉर्म कर दिया जाता है, और एक वो उन्होंने पीईबी का ग्रुप बना हुआ है व्हाट्सएप पे, उस पे भी उनको
ठीक है।
इन्फॉर्म कर दिया जाता है।
हम्म। मेरी आवाज के मतलब कमेंट दें। इज इट कंसिस्टेंट एंड लाउड एनफ?
जी
आपको
जी
ठीक आ रही है ताहिर?
मुझे तो ठीक आ रही है बिल्कुल।
आपकी आवाज लेकिन लहरा के कम आती है। मुझे लगता है आपका माइक के करीब कंट्रोल जरा थोड़ा सा ठीक कर लें।
अब बताएं कैसी आ रही है।
हाँ पहले से कदरे बेहतर है।
चलें, अगर आ रही है तो ठीक है। अब मैं अगर और करीब करूंगा ऐसे,
हाँ दिस इज
और अच्छी
बेटर।
आ जाएगी।
जी 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 जी।
नहीं तो लेट हो वो अब लोग नहीं आए, 50 लोगों ने रजिस्ट्रेशन कराई है, कितने 17 लोग आए थे। मैं कहता थोड़ा सा 20
इसको बताओ, सबको भी चुप कराती हूँ। हाँ हाँ नहीं।
मैं जी जो इस वक्त इनफॉर्मल मैं अनाउंसमेंट कर रहा हूँ उन लोगों के लिए जो नए हैं। ये इसके जो रूल्स में जी एक है कि आप लोगों ने अपनी, जिन्होंने सीपीडी सर्टिफिकेट लेना है, उन लोगों ने अपनी वीडियो अपनी ऑन रखनी है। आपका चेहरा अपीयर होना चाहिए स्क्रीन पे, जो कि हमारे जो यहाँ पे दो PSC के लोग हैं जो मॉनिटर कर रहे हैं। और आपको अगर आपका कैमरा बंद हो जाएगा किसी वजह से भी, तो आपको इंतबाह किया जाएगा बार बार। ये PEC की रिक्वायरमेंट है, ये प्लीज़ आपने अपना कैमरा बंद नहीं करना। और मुझे आपने फोर्स नहीं करना कि मैं दरमियान में फिर कोई अनाउंसमेंट करूं, इससे स्पीकर जो है वो डिस्टर्ब हो जाता है। तो प्लीज काइंडली आप लोग अपना कैमरा, आप लोगों ने वीडियो अपनी ऑन रखनी है और आपका चेहरा नजर आना चाहिए। इस वक्त अभी तक तो मैं कोई देख नहीं रहा कि PEC का कोई नुमाइंदा अभी तक आया नहीं है, लेकिन वो लोग आते हैं और वो एट रैंडम चेक करते हैं। तो ये हमारी जिम्मेदारी है कि उनके इस असूल को हमने जो है वो इम्प्लीमेंट करना है जी। तो शुक्रिया जी, थैंक यू। नहीं वो दिशांत साहब, आपकी वीडियो कैम आपको ऑन नहीं है, प्लीज ऑन कर लें। राना इब्राहिम साहब प्लीज, आपने भी वीडियो कैम अपना ऑन करना है। सुहेल हमारे 20 पार्टिसिपेंट्स हो गए हैं मेरे ख्याल में शुरू कर लेते हैं
लेट अस स्टार्ट। मेरा ख्याल है शुरू करें, अदरवाइज वी विल बी फार बिहाइंड। बाकी आपके इंट्रोडक्शन करते करते कुछ और आ जाएंगे।
जरा उसको बुला लो जी, टाइटल को कहना इधर आके, फिर मुझे इधर जब मैं बोल रहा हूँ तो मेरी इधर नजर नहीं होती। नहीं वो यार लोग आ रहे हैं ना, साथ साथ एंटर भी तो करना होता है, तो एक काम है इधर। अब लोग आते जाएंगे तो एंटर करिए जाना यहाँ से, मैं जब तक मैं अनाउंसमेंट कर रहा हूँ। आयुन बंद करो, जरा थोड़ी खामोशी कर लो, एको वरना। Bismillahirrahmanirrahim. This is your host Tahir Sultan, welcoming you in PSCE's lecture number 20. The speaker today is Engineer Sohail Kipriya, and the topic is bearing capacity of shallow foundation in rock. And before I introduce the speaker to you, I'll explain you first the rules of this webinar. One, as per requirements of Pakistan Engineering Council, you people have to keep your video on. Your face must appear on the screens live. This is a rule which has been specified by PEC, and their representative monitors this situation. So please don't force me to make further announcement on this issue because it disturbs the speaker and his flow of delivery. Thank you. Second announcement which I want to make is, it is regarding the webinar. As you know, the government of Pakistan has eased up the situation regarding social distancing, but still a clear-cut instruction has not come from the government regarding open congregations or open gatherings in the lecture halls. Therefore, the administration of Pakistan Society of Civil Engineers has decided to continue this webinar, delivering the lectures via webinar for a period till government comes up with a clear-cut instructions in this regard. The third announcement I want to make is regarding a survey pro forma. Today, as the speaker will deliver the lecture, on your registered emails, Ms. Sadia will send you a pro forma for your comments regarding this lecture. So once the lecture is delivered and question answer session is completed, kindly fill up the pro forma. We would be waiting for your feedback on the lecture, on the quality of the lecture, on the topic, and if you need any further improvement in the lecture, please let us know. Your cooperation will help us to improve the quality of our lecture. And it's not only the lecture, the technical things also about this transmission on Zoom. And if somebody is on the Facebook, how they see our transmission on the Facebook. Ms. Sadia is going to start sending you the pro forma on your registered emails. There was a third announcement also regarding questions. Our speaker has allowed that you can ask the questions while he is delivering the lecture. But
Yes.
During the lecture, you can ask the questions only by text message. You will text message the question. I will read that questions.
हाँ करो.
Mute. After the lecture is finished, there will be a 20 to 30 minutes question answer session. So whosoever likes to ask a question via his voice, he would be most welcome to ask the question. But the question should be brief and to the topic. That would be at the end of the lecture. 20 to 30 minutes question answer session. So now the announcements are over, and now I will very briefly introduce engineer Sohail Kibriya. This is his third lecture on our platform. He's though he's a guest speaker, but he's also a founder member of Pakistan Society of Civil Engineers. It is his third lecture. And he needs no introduction, but still it is a routine for us to give some introduction of the speaker. So engineer Sohail Kibriya is an eminent engineer of our country. He is known internationally, and he did his he got his bachelor's degree or undergrads, whatever you want to say, in civil engineering in 1980 from UET Lahore. Then he did his master's in geotechnical engineering in 2004, again from UET. And then he has been studying in LUMS for certain courses there also. And his most of his service, rather a bulk of his years, have been spent in NASPAC. He started as a junior engineer there and reached up to the level of vice president, executive vice president or senior vice president, and he retired from NASPAC about 2 years back, and now he has again giving his services to NASPAC on contract. During his career, he has attended a number of workshops, conferences in Malaysia, South Korea, Nepal, UK, France, UAE, Oman, and some other countries. He has gained significantly rich geotechnical experience of working on diverse engineering projects, including nuclear, irrigation, hydraulics, sewerage, drainage, you name it, and he has the experience. And further, Mr. Kibriya has main interests in soil dynamics, ground improvement, foundation engineering, landslides, field and laboratory practices. He has also demonstrated outstanding project management skills too. Further, Mr. Kibriya, as I don't remember if I've already told you that he is the founder member of Pakistan Society of Civil Engineers. So this is a brief introduction of Mr. Kibriya. So Ji Sohail Saab, the floor is yours. Kindly start your lecture. Sorry, Sohail, sorry, we have to please hold up. We cannot unmute you. Please just hold on. Sohail, can you unmute your mic, please?
Well, it's done now. Yeah, it is
okay,
done now.
Thank you. Thank you. It's okay now. Please go ahead.
Problem. No problem.
Ji Sohail, you can continue with your lecture.
Yeah, I'm starting. जी बिस्मिल्लाहिर्रहमानिर्रहीम. I think I'm audible to all. As
Please
already
go ahead.
introduced.
Your voice is okay. Your voice is okay. Please go ahead.
Okay. So today I'm going to talk on the bearing capacity issue of shallow foundations when placed in rock or on rocks. The issue of bearing capacity on rock has been less talked about, and people have little experience because of many reasons. It has been less researched about, but quite recently, in the past couple of decades, a lot of work has been done on this. Earlier practice was that people used to rely on the caudal presumptive allowable bearing capacities for rocks, perhaps considering the rocks to be more complex. So here you see the contents that I'm going to talk about today. I'll first describe some general aspects about the rock. They are important to be understood before going into the discussion of the bearing capacity evaluation for rock. And I tell you that I'll have to go into some formulae and a little mathematics. I've tried it my best to avoid, but I cannot do justice with the topic without going into that kind of engineering approach. But since fortunately you are all engineers, so it must not be something new for you. So after giving a general background, I'll be discussing the in situ, on-site, as well as some laboratory tests which are routinely and commonly required for the assessment of the bearing capacity of rocks. And there are certain rock classification systems, like soil classification systems too. They are important to be given a glimpse because the empirical correlations, which are still very much in use and very much in some famous codes, they are based on the rock classification systems to derive the value of the bearing capacity, like rock mass rating, etc., and the Q system. Then many bearing capacity evaluations in many codes and in a lot of literature, they are based on the failure modes, that what kind of failure is going to take place in the complex system of rock. So I'll give you an overview of various possible failure modes. Then I'll jump to 4 or 5 different kinds of systems for evaluation of bearing capacity in rock. One is the presumptive bearing capacity. The old system used to be just giving charts and tables, and different countries and counties in the world, they have given their presumptive bearing capacity table. But quite recently, the International Building Code and the Canadian practices, they have made some advancement in that. I will be telling you what they have done. Then I'll be giving you a host of empirical methods for bearing capacity evaluations, and those which are based on the test results and analytical methods. And quite recently, we have numerical methods also, which are available. If the time will be available in the end, I'll try to give you some case histories. So let's have a general talk about rocks. First of all, let's have a brief comparison of soil versus rock. You are more familiar with soil. We engineers have been trained to deal with soils more rigorously, which are unconsolidated materials. Particles are separate, they are independent. And in contrast, the rock is a rather consolidated mass of minerals. What's a mineral? It is a naturally occurring solid inorganic substance. So that is a mineral. So you can consider a consolidated mass, you can say, particles assembled together. And well, I'm going to tell you, which is a statement which is not always true, that the worst rock may be, in a number of cases, as good as the best soil, but this is not true. And I've seen that this statement is defeated in case of very weak shales which are occurring in our Murray and Kohala area too. Similarly, in certain other countries, we have very weak chalks. You see, they're a kind of weak rock, very, very weak rock. And sometimes the sandstones are also very friable and very weak. So we'll consider here in this lecture, the bearing capacity with regard to shear failure, that is the ultimate limit state. I will not be touching the allowable bearing pressures with regard to the serviceability limit state controlling the settlement. Rocks are different from soil in that also that they have bedding planes because of their geomorphological or depositional history. They have, in addition, a number of non-conformities and defects, joints, folds, and falls, and fissures. So we can say rocks are more complex. As a natural material, the most complex material. So that's why perhaps it was neglected because enough theories were not present, and you see, people thought that investigation into rock, which appears quite hard, will not be that significant, but that is not true. It is the joints and the weak planes and the cracks in rocks which control their engineering behavior than the properties of the intact rock. So here I would like to differentiate that what is the difference between a rock material, which we call intact rock, which is present in an integrated form, and at site as we see mass of rock spread having weak planes and joints and fissures and faults and shear planes. So there's a lot of difference. The intact rock is the rock material which we obtain by coring, say by drilling operation by coring. So that is a sound piece of rock. It may have good strength, but the rock mass at the site on the whole will be having a lower value of strength. So that is what we have to differentiate between the rock material and between the intact rock. In this slide, you can see if this is a kind of a hillock, a rock mound, and these black zones, you can say that these can be, if it core from there, or you see, the zone between different planes of joints or weak planes, you can see this set of weak planes and an orthogonal set of weak planes. In between is uncracked or unjointed portion. So this is the intact rock on which we are able to find out the strength properties in the laboratory. Otherwise, the whole mass is a rock mass. And here you see now in the figure also that we have a bedded rock having joints also. You can see it has some fractures too. But if we manage to take the specimen out, so that will give us the property of the intact rock, which will be higher than the rock mass itself, because intact specimen of rock is stronger than the rock mass on the whole. Now, what is the role of these non-conformities or discontinuities or joints or weak planes or cracks? Many names are given to this. So here you see the in situ rock and a rock mass is having a lot many weak planes, and these range from fresh to badly disintegrated rock. The behavior of rock mass under the applied loads is governed by interaction of the intact blocks with the discontinuities. This means there are intact blocks between the joints, and those joints may be tight, they may be without any gap in between, and if gap is there, then again there could be two situations. Either the gaps are containing air voids or water, or they may be filled with some material like with clay or with some other material, with sand particles. That is called gouging, the gouged joints. So the behavior is different if the joints are open, or in the other case if they are filled. And here in this figure you see, you have an idea already about the bedding planes. So in this case they are horizontal, and you can see some joints you see running like this. So in this figure you also see joints may not always be vertical, they may be inclined at many angles according to the formation of the rock and the later distribution of stresses within the rock. But the presence of these joints and this weak plane, that increases the permeability of the rock tremendously. That's why in practical situations, we have to consider whether there will be the effect of seepages and submergence to the system of foundations, even if present in the rock, because they serve as the weak planes and they are capable to result into too much seepage, which can exert a lot of uplift pressure on the structures through the foundations. So before passing ahead, I will also like to brush up your concepts about very common terms, which are strikes and dip. So the trend of the beds you see, if there are beds of the rock, as you can see here, so here you can, the base line is the strike line. It has a direction. Strike line has a direction measured with respect to north. And the angle of the beds with the horizontal is generally called dip. And the fact remains that the dipping is considered at right angle to the strike. And here is an interesting rule of thumb that if you take your right hand and keep the four fingers together and take the thumb out and place the fingers in the direction of the dip, as this has been done here, fingers in the direction of the thumb will point in the direction of the strike, right? So strike here, thumb is what thumb is saying this way, so strike is this way. This is a very just simple model just to tell you. And here in this yellow diagram, you see because of stresses, there is a kind of folding. And here you can see the joints in the rock, which are parallel to strike, called strike joints, and the other ones in the dip direction are called the dip joints. And in addition, there will be many shear joints and oblique joints. And here you see tension cracking because of folding. So I'm just telling you, just a brief, that the situation in rock is really complex. And here in this model, you see that in the structure of the rock, many cracks are there. So that is the presence of the joints and cracks, their distribution, how much wide they are. The width of the cracks is called aperture, how much space they are, that is called the spacing between the joints, what are their direction, whether the joints are tight or not tight, and whether they are without any filling or whether they are filled. This all controls the engineering behavior of the rock under the load and controls the bearing capacity. Here, you see a foundation is placed, you can see on a rock formation. Here, this is foundation on rock, and there are multiple sets of joints, and 5 cases have been shown in group 1 to 3. Case 1 here, within this zone of the small circle, this is just intact rock, there is no joint, right? So this will give you the strongest value of the strength. In the second case, there is a single discontinuity, all right, contained in this circle. This is the main discontinuity, which is in fact shown and blown up here. And here in this third circle, you have 2 main discontinuities, this and the one at right angle you can see here. And here, now, as you increase the area and consider more area, several discontinuities. And here, the bigger circle, there are several, even more, so jointed rock. So now you can imagine that if this is a foundation loaded with certain load, then it depends on the spread of the load within the formation, that how much complexity we are going to enter, right? If you can take these circles as the stress bulbs, for instance, then you can see that in the deeper stress bulbs, more variable behavior of rock is going to be met. And since we know that the bearing capacity problem, which is related to shear failure, is confined to the upper zone beneath the foundation, then we can have these distributions as more important in controlling the bearing capacity under a jointed rock. Now here in the sketch you see there's a foundation of certain width placed, just to tell you that the joints in the rock below that just shown for the case of ease as vertical and spaced S distance apart, and the thickness or the aperture of the joints is shown here. This is a jointed rock mass. If here in this case S is less than B, but in real situations, in many cases, S could be more than B. That is one situation. And another could be S could be too much more than B. So that is the case of the intact rock where you don't come across joints under the loaded foundation. So its behavior without joints will be really different. So here I want to draw a line between what we call a continuous and a discontinuous behavior of rocks. When we have joints, the rock system becomes discontinuous. And this is of more importance. A jointed rock is more important to be considered as such in the sliding stability, because then the joints open up and the sliding may take place of the individual blocks and bearing capacity in which the movement may get triggered along the joints or along the weak planes. On the other hand, we may consider the system to be continuous, you see, a continuous system, even if it is jointed, when we evaluate deformations and settlement, because that is based on the average properties. And we don't expect some major movements within the rock because of the movement of the joints and the weak planes and the blocks. To have an idea here about the different kinds of defects in rocks, which have a bearing, which have a control on the load bearing behavior. The inherent weakness of the fabric is not strong or hard enough because of the incomplete hardness or incomplete induration. Less time was spent. Sudden cooling was there if it was igneous rock. Structural defects because of effect of stresses because of the thermal reasons and other reasons, physical reasons. The defects in some cases gets enlarged, you see, by weathering action and by the movement of water. And in certain formations, particularly in limestone, some deep cavities have been observed. And in Middle East, where limestone is present in abundance, this is a big problem that whenever a tall building is considered, they have to find by proper geotechnical investigation like electromagnetic surveys, whether a sinkhole or big cavity exists under the formation or not. Because if we construct a structure and place foundation on the surface and underneath there is a cavity in future, that may collapse and result into a sinkhole, causing excessive damage to the structure. So typically effects of chemicals and slow movement effects, which are in weak rocks, in soft rocks, like in our Murray, Kohala, and the Azad Kashmir area, we have the creeping shales in particular. Collapse of pores in young and soft rock is there, and some subsidences. So it gives you an idea about the kind of major defects which we expect. So whatever I have said so far in introducing very briefly, within the limitation of time, the rock to you, isn't it so that the rocks appear weird? They have their own style. So that is the reason that the design of foundations on rocks was largely empirical. And when I joined the practice back in 80s, I found that mostly investigations were though carried out, but people were not much aware that how to utilize the results of the investigation. So in the end, in a nutshell, tables used to be opened of certain codes and some presumptive values used to be adopted. So the practice has changed since then now. And now we know that we have analytical methods and we have, better provisions in the codes also, and we have numerical modeling as a tool also. But one thing I tell you, like in any other, the situation of modeling and also in soils, the results of the numerical modeling by running sophisticated software and computers will be no better than the quality of the data which is plugged in. And the quality of the data has a lot to do with the in situ testing, with the laboratory testing, and finally, in evolving the representative properties or parameters for rock. That is really a very skillful job.
Hold on a second. Sohail, can you hold on a second?
Yeah, I'm holding. Okay.
Yeah, all participants are again requested. I don't want to take the names here. Please check there are a number of participants whose cameras are not on. I can't see their faces, and please, I have requested earlier also, just see now interruption has taken place, and this would disturb the speaker. Please keep an eye on your cameras, on your videos. Your face must appear on the screen for those who need CPD certificates. Otherwise, don't put us in a difficult situation that the staff of PSC will come to the conclusion that the certificates are not to be issued. Please don't put us in that difficult situation. Thank you. Continue, Suhail.
Okay, Tahir, I'm a bit tough speaker. I'm not really much disturbed to the happiness of the listeners, of the audience, but
Okay,
the
thank you.
talk in
Thank
between.
you.
It's okay. It's okay with me. So, as I've been telling you, if rock is not properly considered, its properties are not properly evaluated with the principles which are present there, we may get surprises. And in engineering, such surprises are not, you see, welcome. So we are all engineers, but we ought to have a reasonable knowledge of engineering geology now. Otherwise, we cannot conquer the area of placing foundations on rocks safely. Just a brief overview of what kind of institute testing and laborating is to be considered in this topic. Well, there is no hard and fast rule like in soil, so it will really depend on so many things like project degree of variation, expected cost and time available, etc. Depend on the experience of the engineer then. So typically, in broad categories, we need to have geological mapping. What a geological map is, we carry out topo survey, prepare a contour map, and superimpose the exposed geology on the surface, including all the non-conformities or all the information that could be picked from the surface of the rocks. So that makes a geological map. The information about folding, faulting, dips, strikes, joints,
Suhail,
whatever is
Suhail, we have a
needed.
question.
Yeah,
We have a
yeah,
question.
please. Can you please read for me?
Yeah, the question is from Muhammad Imran, and he's asking, does slopes made in rock can be regarded as a fully guaranteed for their stability during their service over a period of many years?
Imran, how can this be possible unless they are the engineered slopes and proper hard engineering work, understanding of rock has been done, and if required, in many cases before placement of foundations on bedding material, when the beds are not, favorable. There are two situations. Sometimes the beds are favorable, they don't trigger sliding. Sometimes they are unfavorable and they can trigger sliding. This has to be determined beforehand, and if the structure weight through foundation is being put on rock and that may cause movement along the bed, that is very serious. In some cases, the beds have to be held back by certain operations. One operation is bolting or nailing in the beds. So just saying that if the slopes are provided in rock and then it is guaranteed that they will last is no good a statement. They may not last unless all the precautions and all the due procedures are adopted properly. So I was talking of geological mapping, then drilling using proper drilling mechanism in which the cores through the rock, long specimen of the rock in their natural form, that's called a core, they are recovered. Certain tests in the field at site to have the rock mass property, because in the laboratory, normally we will measure the intact rock property, and then a series of laboratory tests to have an idea about the properties of the rock in the laboratory. So we are aiming at basically these main characteristics. We need to know how porous the rock is, how dense it is, what can be the sonic wave velocity in this, what is the degree of fisting, jointing, or defects, and what could be the order of permeability. that indicates the state of openness of the joints too, and the aperture of the joints also indirectly. How durable the rock is from chemical aggressivity point of view and how strong it is. These are the main characteristics which are required. And to achieve these characteristics, these laboratory tests, as you see on the screen, would commonly be carried out for projects where the foundations have to be placed on rocks. Absorption of water, the specific gravity, the durability of rock on exposure. Some rocks get slaked when exposed, right? They get disintegrated. Unconfined compressive strength is one basic property, and there's another test which measures the crushing strength on an irregularly shaped specimen that is called point load index, also convertible into unconfined crushing strength. Triaxial compression tests, like in soil, but they are not that common in rock. They are expensive and more robust arrangement has to be done. Splitting tension tests, like we carry out split slender tests in concrete, 4-point flexure to find out the flexural properties, the lab, ring shear, hook shear, etc. So at least you know the names, those who are less familiar, and they can later carry out search on the Google or in the standard literature, in the books, in the codes, to know that what these are about. The purpose of my lecture is to expose you to so many different things. This short duration of the lecture cannot do justice with the topic. So you will be getting prompts, and then later on, those who have interest can go and read more. So likewise, like laboratory tests, you have a series of field tests. Depending on the type of project and its importance and the budget available. One is the flat jack test. As you understand, when you jack a case rock, you are in a position to have load versus deformation behavior. And if the failure takes place, you get the ultimate load. Like we carry out plate load tests on soils. We carry out plate load tests on rock on the surface. After breaking the surface, going a little deeper, or in the borehole at different levels using a small plate and a loading ramp. So basically, the test mechanism is the same, and the method of getting interpretation of the results is also similar to what we do in soils. And then it's a good test for finding in situ shearing strength parameters of rock called in situ direct shear tests. Like laboratory direct shear tests on soil, which is a small scale, what we do is that we put a confining pressure on the soil and then find out by gradually increasing the sliding load, the shearing load, that what shearing load will cause ultimate failure. So it's a large size equipment, but having the same principle at site to find the C and phi, cohesion and angle of internal friction parameters. Non-destructive testing techniques like geophysical methods called
So here there is
seismic.
a question.
Yeah, please.
The question is from Mr. V. I don't know. I think this is not the correct name. This is some sort of a ID, Vivo 1907.
Oh.
Sir, can UCS from point load give us representative value as compared to UCS from universal testing machine? Furqan
Yeah,
Hamid.
please.
This is Furqan Hamid.
Furqan Hamid Saab. In fact, the basic difference between a point load test and the unconfined compression strength test is that when we have limitation of the core size, its length and diameter, rather we have just a small irregular piece, we can put load onto it at 2 points you see in the equipment and then find out the strength you see. So through a separate index, which is available depending on the diameter of the core which was used, you see, the coring equipment which was used, and some other adjustments, we can have a very good reasonable idea. You see, we say that something is better than nothing, because if you don't carry out point load test, then you don't have much information about the strength. This is particularly true when we have excessively jointed rock and we have very few number of cores which can be tested for unconfined test, or no core at all. Then the best option would be to find the strength and crushing behavior by the point load test. Okay, fine. So similarly, we do carry out for seismic designs the shear wave velocities and the compressional wave velocities by crosshole, uphole, and downhole tests. Crosshole tests, uphole, and downhole are like what we perform in soils. Crosshole tests would imply that we make the seismic energy to travel horizontally from one borehole to the other, so that at that particular level or horizon, we are able to find out the shear wave velocity and the compressional wave velocity, which are the basis to find the dynamic elastic modulus and dynamic Poisson's ratio and shear modulus, etc., etc.
Suhail,
Uphole test would, yeah, please.
sorry, Furkan has supplementary question. What
Hello,
if what if
hello. I couldn't hear you. Yeah, I'm listening, but there is no voice from you, no sound from you, Taisa.
Can you hear me
Hello,
now?
hello,
Can you hear me?
hello.
Yeah, can you hear me?
आपकी आवाज नहीं आ रही. Hello,
Can you hear me?
hello. Can you hear me?
Yes, I can hear you.
आपको मेरी आवाज आ रही है? Hello.
जी 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 आ रही है. जी Suhail, continue please. तो ये मसला अब आया, इसको बता दो, सर्टिफिकेट नहीं मिलेगा. जी, can everybody hear me? If anybody has a problem in hearing me, please raise your hand. The speaker got disconnected. He is coming back. Please wait. Thank you. मेरी आवाज आ रही है? So we are waiting for the speaker to come back. He got disconnected. I really don't know what is the problem. So we are contacting him on phone also. So let's wait for him. rebooting हो रही होगी मेरे ख्याल में. We have contacted the speaker on telephone, and he is facing some issues with his internet, which at his end, and he's trying to fix it. So we have to wait for some more time. Let's see how soon he can come back to his lecture. In the meantime, I really have nothing to say, just except I can remind you that please keep your videos on. Your face must appear on the screen. That is a requirement from Pakistan Gene Council. So we have to follow it. And now let's see how soon he can come back. I will take advantage of this interruption to make another announcement that this is the last lecture of PSCE being delivered from the present location of PSC's office in Township. Uh, the location of the office location is going to change. It's going a little bit far out of Lahore. So we have another office in Model Town. The address would be given to you. So now if this lecture continues and the certificate distribution of the certificate will take place from the new office. Uh, this office will be operational till 25th of August. Thereafter, this office will close here, and the office of PSC will shift to another one in Model Town Extension. The address will be emailed to all of you by Ms. Sadia, and from there you people can collect your certificate. Now let's hope the speaker comes online as soon as possible. He is still not there. उनको को फोन से हॉटस्पॉट चला Yeah, I can see the speaker. He is now joining. So, welcome back, Sohail. Can you hear me? Sohail, can you hear me? We can't hear you. Your mic is not in a unmute position. Please unmute your mic. Sohail?
Can you hear me now?
Yes, for sure. Please go ahead.
So there has been a lot of embarrassment. I don't know what happened. Anyway, let's forget about it. I think you were going to put some question from someone.
Yeah, that was a supplementary question from, let me go back and scroll up.
Your sound is low. Can you keep your mouth close to the mic?
Yeah, Furqan Hamid asked a question, sir, can UCS from point load give us representative value as compared to UCS from universal testing machine? So you answered this question, then he had a
Okay.
supplementary. Then
Okay.
he had a supplementary. What if sample is destroyed during the coring, sir?
If the sample is destroyed during coring, it is an accident. And in life, there are accidents. In the life of an engineer, there are several accidents. So if the sample is destroyed, it's okay. We have to live with that. If we have other samples, try the other sample. If we don't have any sample, then we cannot get directly the crushing strength. If we can use a point load test, well and good. Otherwise, there are other ways and means. I'll explain to you how we can find out from the rock classification also the good estimate of the crushing strength. Okay, we will have to go by indirect methods. So just a minute. Now let me go into full screen mode. Yeah. Now let me tell you another common term, which because this is what is called RQD, abbreviatedly rock quality designation. This is also correlated in literature, in codes also, to the load bearing capacity on rock. So it is appropriate I define this very briefly. When we drill hole in the rock and recover core, the coring operation is done in runs, say a meter or less than a meter, and then we recover the core out, and then the subsequent 1 meter, and subsequently you see like this. So the coring goes in steps, and we find out that if the number of pieces, the total length of the pieces which are more than 4 inches or 100 mm, what is the total length? We find out that divided by the total length of the coring run, the depth of the penetration is the coring run. Expressed in percentage is RQD. But since if we have a good quality rock, there is a likelihood that the total length of the pieces of rock, the fragments of rock, more than 4 inches in length will be more compared to a shattered rock. So it is an index of the rock quality. So here in this figure, you can see that this is a core hole. And here you see on the left side, core recovery. You see here the runs are only 250 mm each up to here. This is 200 mm, 250. So these coring runs combined together, you see, will amount to 1200 meters. And the core, the total coring run is 1200 meters, and the core which is recovered is this much, 96%, right? But on the other hand, if you see on the right hand in this figure, we have in this coring run 250 mm of core, and here total length of cores more than 4 inches, more than 100 mm is 190, and here it is 200. So these three lengths together, which indicates the cumulative length of core pieces equal to or more than 100 mm, divided by the total length of penetration in the rock, right? Expressed in percentage, this is RQD. Whereas the core recovery is 96%, the rock quality designation is only 53%. It's not that good. It is an average type of rock. Now, let me jump into, please.
The question is from Q. These people don't write their correct
People
names.
should write their names. Yeah, this is
Omar Maqsood. Omar Maqsood. Okay, he has written Omar Maqsood. What if the RQD? What if the RQD is almost zero?
Well, when the RQD is zero, you have Punjab Urdu में जिसको चूरा चूरा situation कहते हैं ना, badly shattered rock, right? RQD zero. All the pieces, all the fragments are less than 100 millimeter or 4 inches in the whole length of the borehole. So RQD zero is very, very poor rock. Let's go into small discussion on the rock classification systems. Rock classification systems are for rock masses as they exist at the site with all their defects and discontinuities. One famous system is called geomechanics classification system due to a famous name, Binyowski, and it provides a parameter called rock mass rating, RMR. RMR is nothing but a mathematical number from 0 to 100 divided in 5 stages or 5 groups. 0 being the poorest rock and 100 the best rock, strongest rock. I'll tell you that what is recorded and how it is. It, you see, gives you evaluation of certain parameters which are added up to result into a number which is seen that where does it fall. The other system compared to RMR is called Q system. This was developed by NGI, Norwegian Geotechnical Institute, also called Barton system. It is slightly different and queer. The rating is from 0.01 to more than 400. It's like that. Let's go quickly. Rock mass rating system from 0 to 100. Increasing, the number is increasing with the quality, with the strength of the rock. So what variables this system consider to classify the rock? One is the strength, crushing strength, unconfined compressive strength, the RQD which I've just told you, the spacing between the joints, which is the aperture or width, not spacing between the joints is the interval between the joints, how much they are apart. Joint condition, the groundwater condition within the rock mass, and influence of orientation of the joints on the work. Now you have a look here on the left side is a small table. It relates a rating factor for different values of RQD. Like in the previous example, the RQD was 53%. So it falls in this range. It assigns a rating of 13 for that RQD, right? Now we have to add up the ratings obtained from these different tables. Second rating is for the point load index value or unconfined compressive strength value. Just a minute. Here you see for different, say the unconfined compressive strength is something like 25 to 50 megapascal. So this will give a rating number 4. So that 13 to 4 added to 4 becomes 17. Oh, here another variable is what is the condition? Just a minute. Rough surface.
Another question.
Yeah, please.
On which criteria bearing capacity is calculated in rocks in which RQD is 0? Because UCS is not possible on such recovery.
Okay. What is the name of my friend?
Umar Maqsood.
Mr. Umar, you are going a bit ahead. Please listen to the lecture. The remaining parts, you see, they will give you adequate information on your question. I'll show you a relationship of RQD correlating rock quality designation directly with the allowable bearing capacity to be considered, okay? So here you see the conditions of joints give this kind of rating, and here the spacing between the joints, right? Wider the spacing, stronger the rock, and hence higher the rating factor. अभी किसी ने कहा था ना कि अगर बहुत उसकी RQD 0 हो, so when joint spacing is too narrow, करीब होते हैं, then no core is recovered, you see. You get chura, you get all shattered. So the rating factor is low for that. Here is the rating factor for the groundwater situation. Either this or joint water pressure tests are carried out by the divided by major principal. So this gives rating here. And similarly, when we have assessment of the orientation and etc., we get this kind of rating. So you see, we add up all those 6-7 rating factors to result into one number. That one number is called rock mass rating, and you see there are 5 classes, 5 categories, ranging from very good, 81 to 100, and very poor, 0 to 20. तो ये तो एक आसान हो गया, लेकिन आपने देखा that this requires a rigorous study of geology. ठीक है ना? So this is the area where geotechnical engineering, which is a branch of civil engineering, interfaces with engineering geology. ठीक है जी? Other system, Q system, what does it say? It gives a mathematical relationship in which different variables are defined. So how to evaluate them is also shown. I'll show you. So one variable is RQT. Second is the number of joint sets. How many sets are there of joints? JR is the roughness, how rough the joints are, whether they are filled or not filled or unfilled. That is important. JA. What is our condition of water? And what is the stress reduction factor? So here you see, to plug in these values, you have to pick the values from here. RQD from the coring record, and JN, JR, of course you can see from rough joints to smooth, the values are changing. So whether they are filled or unfilled, right? What is the water condition? They are containing water, whether they're dry or containing flow of water or what. And what is the condition of the stress reduction class? Okay. So based on these values, you plug in these 5-6 parameters, but a geological study is warranted, detailed geological study at the site to find the rock mass characteristics. And here you get some value less than 0.01, which would be rated as exceptionally poor, and more than 400. How many classes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 classes compared to 5 in RMR. So Q system has 9 classes. Here is a table which places RMR and the Q values together for the sake of comparison. It gives you a comparative feel that when you have an RMR of 60 to 80, rock mass, you are in Q system between 10 and 40, right? So accordingly, here, this is your expected cohesion angle of internal friction and other properties. So you see an estimate. A lot of work has been done on the basis of the data using these parameters. So far, we have discussed even rock classification systems, and I'm gradually dragging you towards the evaluation of bearing capacity. It was not possible to jump into that straight away, otherwise you would not have understood even a word of what I've been talking about. Now, this is the last part before we start discussing the bearing capacity directly. Failure modes. The bearing capacity calculation in rock is dependent on what kind of failure is going to take place. Again, please, I showed you this slide earlier too, that imagine that rock system under the foundation, below the foundation, is having some joints which may be closely spaced or widely spaced, spacing may be less than the width of foundation, or maybe more than, or maybe much more than, right? And the thickness, there is a thickness of the joint, whether a few millimeters or a few centimeters. and whether they are unfilled or whether they are filled with some material. So this changes the behavior. I couldn't get a better image. I didn't have time to draw myself. That becomes a very rigorous exercise, but I think I'll be able to explain. Here you see two failure modes. I call this a local shear failure mode because its zone of failure is confined compared to this, which is a general shear failure mode. Both are the failure modes which can take place in intact rock depending on their strength and on their induration, on their toughness, right? This behavior, which I call local shear, which is confined, limited in extent, is called brittle behavior, and the one which involves more rock mass during failure is called ductile behavior. ठीक है जी, ये दो मैंने एक तो आपको बताए when intact mass is there, and the mathematics and the relationships and the procedure to calculate the bearing capacity in rock for these two failures is distinctly different. As you know, for soils too, we have different.
Here we have a
approach for
question.
finding. Yeah, please.
Now this question is from Furqan Hamid. He is asking, what is the difference between RMR and Q system, and how will know where to use which system?
ये देखें, I've explained the parameters to you, right? And this is how RMR is being shown correlated to Q. So here you can have a feeling of the comparison. Furqan sir, I think you are understanding this, okay? And this is rock classification system, like we have soil classification system. करते थे ना उसमें ASHO system में A1, A2, A3, A4, A5, A6, A7, and in unified system SC, SM, GW, GP. ये उस तरह का rock का classification system है. It doesn't assign a symbol, but it assigns a number, right? Higher number indicates stronger rocks in rock mass condition. In situ जैसे वो mass की form में पाई जाती हैं, and the lower numbers indicate poor rocks. ठीक है जी, आगे चलते हैं. अच्छा, ये मैंने आपको दो failure mode ये बताए हैं which pertain to the intact rock, right? But rocks are not always intact. Just did and jointed rock, how the stress zone that changes its shape according to the joints and the bedding planes. Here you see it tends to become narrow. Here it tends to conform and negotiate according to the shape of the joint. जहाँ ज़्यादा लंबा bed ये joint है, here it gets elongated and it tends to reduce or shrink at right angles. Similarly, it is more evident here. And here you see its lateral spread is minimal. Can you see its lateral spread is minimal, and here it is also going along the stressing is of these beds only. This is important to know that in a bedded or in a jointed system, normally there's a likelihood that we are going to put more stress on those beds, you see, which are directly loaded, right? Their properties become more important. This diagram on the basis of some numerical modeling, but just to convey that if this angle alpha, can you see angle alpha in the figure here? Which is the angle of the failure wedge on the extreme left or right with the horizontal. If this angle is changed, which determines the spread of the failure zone, you see how it changes, and this all then depends on the jointing arrangement, the orientation of joints, closely spaced and this way oriented, and you see this kind of orientation. आप देखें ये सारा इस तरह फर्क हो जाता है. Now I just give you a feel. I'm just giving you different feels. Yeah, please.
So, yeah, Furqan has asked another question.
Yeah, please.
Is there not any standard system for classification?
Furqan Sahab, these are the only standard systems. These are not standard, not designed by Sohail Kibriya. They are used the world over. I am talking of the standard systems. In the best codes of the world, they are the systems. Okay? I've told you 2 systems. आप इसको जाके supplementary reading करें. यही तो standard system है. Why did you, now I'll ask you, why did you consider these to be non-standard? Please give comment. अभी दरमियान में आप comment लिखें और मैं उसका जवाब सुनना चाहूँगा आपसे, okay? Jointed rock mass जरा देखिए. When we have joints, can you see, for the sake of explanation, vertical joints are shown. अब situation ये है, either they can be opened, no filling in of these joints, right? Or they are gouged or closed. या तो बंद है, narrow है, या उनकी filling हुई हुई है, right? Now there are 2 situations. One situation is that the spacing between joints is less than the width. So under the you are expecting some joints. Had the spacing been more than the foundation, and when it has been too much excessive, then perhaps many foundations of a structure would not have any joints underneath them. वो एक scenario बदल जाता है. ठीक है जी. इसमें failure mode इस case में when the joints are open and when S is less than, spacing is less than the width, you see, this is like failure of a column. You see, a failure of a column. Unconfined compression strength will govern here. When they are tight and closed joints, still S is less than B, then it is a kind of general shear failure which will develop shear plane. And the shape of the shear plane will be governed by the shape and the distribution of the orientation and the non-conformities. On the other hand, when we have widely spaced joints, in which spacing is more than width, here joint is here and joint is here, and width of the foundation is less than that, whether they are open or closed, failure will be by splitting mechanism. इसको splitting कहते हैं, ठीक है जी? ये split हो जाता है.
Well, Furqan Hamid has come back with a comment.
Yeah, please. Yeah. I would like to listen.
He is saying both systems are standard. I want to ask which system is more reliable, or we will use both systems and then we'll see which will give us a safer design.
Well, both systems are meant to give safer design. Since this NGI system has been developed, the Q system has been developed in Norway, and basically it is meant for the design of tunnels, to understand the mechanism of rock for tunnels. The practice is that we require more rigorous and precise information of rating also in tunnels. So Q system is very popular for tunnels. For foundations, RMR system is good enough, but it's not incorrect. It will not yield incorrect results, and 2 systems are not required for considering foundations on rocks. Your RMR system should be adequate. You see, RMR system should be, both are empirical. So I just told you the correlations between the 2 systems also. It is a very subjective argument to say which system is precisely mathematically more correct. You see, there are so many assumptions and so many picking of so many parameters, as I've told to you, so you can see yourself. Now, again, discussing the final figure here, I think you can see where we have inclined beds. There's also a general shear failure mode, but the shear failure plane follows the inclined bed. इसका मतलब बेड्स का जो मौजूद होना है, that defines the shape. अगर इससे पहले होता, shearing could have taken place earlier, giving you lower bearing capacity. Likewise, when we have rock overlying soil, a rigid surface overlying a softer medium means it is akin to rock on the soft medium. When it is relatively thicker, you can expect a flexural failure, but when it is relatively thinner, you can express this kind of, you see, punching kind of failure, right? Under the foundation, rock punching into the soil, foundation punching through rock going into soil. And again, this mode of general shear failure when we have irregular surfaces, you see, etc., rock mass. So ये बहुत सारी चीजें हैं देखने वाली. I think I've already explained this. Here you see under intact rock, you expect in fact A, B, and C are 3 different modes of cracking. This cracking, more severe cracking results into crushing. And here, this is called kind of wedging and results into some sideways movement too. Here, a weaker rock and more porous rock is likely to undergo punching, or a weaker layer on a stronger layer over the weaker medium can undergo punching. And here you see shear failure of a rock like soil, which is a weak rock or a strong rock. You see, in both the shear failure can take place, of course, at different loads. I think we have already discussed these modes. Yeah. Yeah, this is interesting. Here you see on the extreme left, hypothetical shear zone may develop like this when the closely spaced tight joints are there, or the joints are there, they are filled in. So it undergoes like a general shear failure case. But when we have open joints here, nothing in between them, the loading will be transferred mostly to the blocks, a local shear failure case in which the rock blocks which are separated, they will receive higher stress shear and the failure load or bearing capacity will be lower. Here the joints are widely spaced so that the spacing between these two joints is more than the width of the foundation, results into splitting. And this kind of situation will also take place in intact rock because intact rocks will split. Here you see there are pinnacles of rocks, they will get crushed. Noking pinnacles are they're pointed shapes on the rock, of the weathered rock on the top. So they get crushed. So they got to be removed for better placement. It's not only that we evaluate the bearing capacities in rock, we have to look at the condition of the rock and we have to take some measures also, like I talked of providing boards to hold the beds. Here you see, it's not only that this part of rock is chopped off to allow the foundation to be placed horizontally, rather lean concrete is also filled here to provide proper bearing on the surface, right? Even if soil is there in between, that should be removed and replaced so that the modulus of the two mediums, the rock and the concrete, is not much different. These are the common situations that we come across when placing foundations on rocks, and so foundations of one structure may be placed in rocks of variable conditions, right? So having said that, I think now you are ready to go with me into the venture of considering evaluation of bearing capacity of rock using different procedures. First of all, the big comment is that the lecture is confined to the discussion on the calculation of the bearing capacity, which is concerning the ultimate limit state. That is the maximum pressure that can be put through foundation onto the rock, which will inhibit the shear failure of the ground. We calculate the ultimate bearing capacity, applies a safety factor, and get an allowable bearing capacity, and control the ultimate limit state. Ultimate limit state can be reduced to allowable load by dividing with a factor of safety. What factors we have already discussed, but just as a reminder, which will finally affect the bearing capacity. So things are not simple, it is a jargon. Type of rock, it's a one variable, the joint spacing, the joint width or aperture, whether joints are filled or whether they are empty, unfilled, how many joint sets are there in different directions, how wet the rock and the joints are, whether there are voids present in the rock mass or not, how thick the beds are or how thin they are, what is the angle of their beds to the horizontal, the dip, what is the direction of the beds with the north, slope of the exposed rock face, which can get weathered, and what the extent of weathering already having taken place, how high the freestanding face is, that is also a factor. Another factor you see, which is covered up partly in this is whether the beds are favorable or unfavorable, whether they can trigger sliding, or if the beds are going into ground, they are considered favorable. If they are exposing out and they can cause movement of sliding by loading to the foundation, it is typical condition in bridges on the abutments, then they are considered unfavorable. They have to be held back or their condition has to be assessed. Distance of the causative fault from earthquake point of view, earthquakes are generated by faults at certain distance, and the length of the fault and the distance that matters, how much peak ground acceleration could be generated, and what are the dynamics during ground motion. What kind of ground motion will be there, how much it will last, the significant period of vibrations, and what kind of displacements it can cause into the rock mass on which the structure in the form of a building or a bridge or anything else is sitting. Well, I've already covered that even today building codes are used for presumptive values. Presumption is the term which is different from assumption. Assumption is just very much assumed. Presumption is the one for which we have some basis, which have some truthfulness, you see. It may be experience even, so that is presumption. So the codes give the presumptive value. It has some proven record of experience and success. And recent studies have given many other methods also. Let us discuss. So 4 main categories I'll be talking about one by one. Building codes, how do they give the bearing capacities? How do they cover? Rules of empiricism, in which experience is used and certain correlations have been given and certain graphs or equations have been given. The loading tests and analytical methods combined with the laboratory practices. Analytical methods would cover the longhand methods as well as numerical modeling. You can include that, which is rather the recent you see inclusion. So we know that when we say bearing capacity of rock has to be determined, adequate stability, tolerable deformation, and of course the system has to be cost effective. So tolerable deformation is the topic which is covered under serviceability limit state, will not be discussed here. I would like to highlight one important structural aspect of the rock too, which is interesting, that sometimes it is the limiting structural requirements which control the design, like design of foundation, size of foundation will be controlled by the minimum size of the column base plate or column at the base. And the size of the column is governed by the load from the superstructure. So even if a lesser size of foundation may be possible, but we will not give a smaller size, smaller than the size of the column itself. And similarly, there may be situations when we have stronger rocks and the concrete has lesser strength than the rock itself, very strong igneous rocks. In that case, there's an option to use high strength concrete and save in some other way in the structure, right? So type of the rock materials and the superstructure itself, they are interrelated. अच्छा जी, ये देखें, some codes spelling out the presumptive bearing capacities in tons per square foot and kPa, just on the basis of hard sound rock. It's very broad, medium rock. What is a hard sound rock and what is medium and what is intermediate soft. It is also decided on the basis of RQD, on the basis of rock mass rating, and on the basis of unconfined compression strength. तो आपने देखा इस table में we have from 8 tons per square foot up to 60 tons per square foot is very high. Here I show you the rocks are described more properly in a bit more detail. Crystalline, sedimentary, only 4,000 pounds per square foot, which is 2 tons per square foot. And you know that 2 tons per square foot or even higher we gives in good soils. For gravel sand mixture, we give sometimes more than 3 tons per square foot, 4 tons per square foot. So here for gravel, this code is giving 3 tons per square foot. Anyway, this is the way they're giving. So similarly here for igneous and uh, sedimentary rocks, so you can see the values of allowable pressures. You see 750 kPa means 7.5 ton per square foot. So the many codes giving different values. Here you see this is more elaborate code. This gives you values for different rock types and categories. Dolomite is a kind of crystalline form resembles that of limestone. Calcium, magnesium carbonate. Different categories of limestone and other rocks also. You can find shales also and different types of shales. So you see different rock types. And they have been covering, you see, basically this is based on different states of USA and some parts of UK too. Is there any name of any Pakistani rock type? Just think why it is not there. Because we don't work. So there are different codes now. That was a very simple way. There's another way that you know the spacing between the joints on the horizontal axis and know that different kind of failure theories are there. We see that which kind of failure mechanism, failure theory best suits and find the value of n sigma. N sigma is multiplied simply by the unconfined compression strength. Unconfined compressive strength. So this is another way which is related with the thickness of the joint. So it is very, I would say, also crude because doesn't consider whether the joints are open or gouged, but this is an approximate method. So similarly, there's a
So here we
Canadian
have,
practice which uses similar. Yeah, please.
now this question is from Mohammed Imran. He's asking, does ground improvement is necessary for rocks?
Ground improvement is a term which is normally used for improving the strength of ground of soil. When we have to improve rock, as I've been talking earlier, I've shown you some slides also in which the rock needed improvement. Concrete had to be filled, replacing the soil, or the narrow pointed pinnacles had to be broken and proper bearing surface had to be provided, or when the beds are unfavorable, we may even bolt them. Sometimes grouting is done, and sometimes you see we provide wire netting on the rock surface, and sometimes we sprinkle concrete, lean concrete with small size pea grain size coarse aggregate that is called shotcreting. So we prevent weathering and water ingress from the top. So this, and sometimes we provide good drainage measures within the rock mass to improve its strength and durability. So these are all rock mass improvement measures, you can call them. You're right that ground improvement or rock mass improvement measures have to be there, right? And now I'm going to tell you what Canadian practice is. It's just like the formula of the building code, n sigma multiplied by the unconfined strength, and in place of n sigma, they have their own coefficient k, capital K, small sp. Now, capital K sub sp has been mentioned here in the form of this equation. What it is? Very interesting. C is the spacing of discontinuities. I've already told. The center to center distance between the joints. B is the width of foundation, and delta is the thickness of the joint, the aperture. So this lead to find KSP, right? And value of KSP is here, and rather you can find KSP using the from this graph. Either you plug in the equation C delta and B, or use C over B ratio and read for the appropriate delta over C to find KSP, and then multiply it with the unconfined strength. ये भी code का तरीका. अब देखें, now this is also in a way a presumptive way, but with some calculation. It's a better calculation जिसमें इन्होंने joint की काफी conditions को उसमें शामिल कर लिया है. ये एक और है, Eurocode 7 uses this kind of method. It says that you have this spacing between the joints here and unconfined compression strength, different curves दे दी गई हैं. You see this versus this and read the allowable pressure here at the base. ठीक है, ये different तरीके हैं which are simple, quick estimation. And now some questions were there earlier that how rock quality designation has been correlated with the allowable bearing capacity or allowable bearing stress. Here you see it is a pioneering work done by Peck et al. And his colleagues in '74, and is considered reasonable. It's a relationship using this equation, right? You can see it is self-explanatory. And it says that use maximum allowable stress to be less than unconfined strength. उससे exceed ना होने दें, even if the unconfined compressive strength is higher. ठीक है, आपका allowable stress अगर इससे कम आ रहा है तो कम को इस्तेमाल करें. Q is unconfined strength, right? जी. I think this is interesting. This is empirical. That how RQDs, how rock mass rating, the classification which I told you earlier, that this is used for finding bearing capacity quickly, empirically in formation. So this is the relationship which is given in the literature to convert rock mass rating. If it is 40, you get how much? 1.4 MPa, which means something like 14 tons per square foot. Now, just have a throwback of what I've been telling you about the failure modes. When the rock is sound and it is intact, the joints are widely spaced. This kind of mathematical relationship can be used to find the ultimate bearing capacity. And this is how NQ, NC, and N gamma type approach can also be used, you see, in the bearing capacity. And this is how RQD is again used, multiplied with the ultimate bearing capacity for intact rock. Square of RQD multiplied with the ultimate bearing capacity of the intact rock gives you the value of the ultimate bearing capacity for the rock mass. So to have the influence of jointing through RQD built up in the calculations. ये एक तरीका है इसका, ठीक है जी. ये उसी तरह I told you earlier, I think I've shown you is a mathematical explanation and definition of the same terms. The Canadian practice, joint spacing at aperture. I showed you the graph also. And QC is the unconfined compressive strength. ये उसी तरह का curve एक अलग दिया हुआ है. And calculated values require some adjustment for these groundwater conditions and cavities. ठीक है जी, मैं बहुत ज़्यादा इसकी तफसील में नहीं जाता. And here, just briefly, I'm touching rock foundation problems, some of the problems. Soft seam in rock, ये मैंने पहले भी दिखाई थी. This is a soft seam, soft layer, right? Replaced with concrete so that the bearing medium is having equal strength, like more or less like rock. अभी एक question भी आया था that have we to improve ground? This is the kind of improvement of the rock mass, case to case basis. So you see, if you have a structure, a bridge, a big building, and or a series of buildings, you see, like I came across different kinds of situation for placement of rock foundation when the NUST campus was being developed in Islamabad. Virtually under every building and every foundation, there were different rock conditions. So that was very challenging. I had to consider every structure and its every foundation carefully, separately, that whether this requires some treatment or not, and if requires, what kind of treatment. Here you see steeply dipping rock surface. So can you see steel bars like anchoring has been done? So here, gently dipping rock, you see the whole foundation has been placed on this. Here you see steeply dipping rock, bolting has been done. This is one ultimate measure to check the unfavorable joints. Why I'm calling them unfavorable? Had they been in the direction of the boards, the joints or beds would have been favorable, because then under the load, the sliding would not have taken place on the open side. Now under the load, if the load is heavy, the sliding can well take place on the open side. So they are unfavorable. That's why they have been fastened or held back. Here you see harder rock like we have in Maris and Kohalas in Pakistan, alternate beds of shales and sandstone. Sandstones are stronger and shales are weaker. So in those cases, the better practice should be select the sandstone beds and place the foundations on those. Don't place on the weaker formation. Here, when we have differential weathering kind of situation, so here the weak material has to be removed. This is called also sometimes dental treatment. You see, like a dentist gives treatment, you see, before making his operation. So we also make a bearing surface by doing dental treatment. So here you see soil and rock. So hazard of high differential settlement is there. So steps have to be taken to remove the difference between the deformation capability. These sets of equation correlate the ultimate bearing capacity with parameter J, C, and NCR, where J is the correction factor, which is dependent on thickness of the foundation rock and width of foundation length, and NCR, this one. C is the unconfined strength, and NCR is determined by this equation when we have knowledge of the spacing between the joints and phi. So you see, there's a wide, scatter of methods and procedures available. I would say that for a given situation, what one can do is, for relatively young engineers or with less experience, unless you have your own, database and your own experience record to guide you, then you can calculate the bearing capacities by a few different methods and pick the least value. I think that is one good approach. And one good approach is that when you have so many codes and so many books available, that a principle applies in common civil engineering too, that you go with the latest, most credible and the latest code and the latest books. Don't use old books and old theories. They are outdated. Use the latest practices. Don't use the old practices, right? Because there is a difference between the two. There's a new trend which has come up, and it's called, in our geotechnical engineering and in rock engineering also, linear genetic programming. You can read on this, Google and read what is LGP. It is basically nothing but prediction versus performances evaluated. And on the basis of that, it's not only the theoretical value of the bearing capacity, but the bearing capacity is adjusted on the basis of prediction versus performance relationship. So this is something interesting field, and I think this is as per the requirement of good engineering practice, where we have some record of performance or where we can collect some performance data of some earlier works in similar situations. Some comment by someone.
We have a question.
Yeah, please.
The question is, again from Mr. Furqan Hamid. What kind of
Yeah.
rock bolt will be used? SN or expansion shells or swelled? How would we know the condition to use appropriate rock bolt? This is question number 1. And then Mr. Muhammad Imran has asked, does factory, sorry, not factory, he has written it wrong. It is, does factor of safety is same for all type of rocks? These are the two questions.
Types of bolts, you see, it is a big question, and the scope of this lecture definitely cannot answer. That requires a few separate lectures. What kind of bolts and their designs and in what formation. But one thing is essential. The bolts have to be adequate vis-a-vis the incipient movement or the load which can be caused by movement of the beds, you see. The resistance has to be sufficient by providing bolts. Such should be the cross section and type and the yield stress of the bolts and their number. I cannot answer, you see, this question because it is subjective. The answer is highly subjective, depends on situations. And Furqan Sahab, this is what I can answer, you see, in this lecture for you. And ये क्या बोला था इन्होंने, factor of safety, different factor of safety for different rocks or same?
No,
Well,
what you have asked is, does factor of safety is same for all type of rocks?
पहले तो क्वेश्चन को भी थोड़ा ठीक कर लें इंग्लिश में. Does factor of safety is same? Is factor of safety same? ये कहना चाह रहे हैं मेरा ख्याल आप. Does को रिमूव कर दीजिए. Same और different.
मैं कोई अपनी सेंस इस्तेमाल करके ना तकरीबन कोशिश करता हूं. मैं
मैसेज जो जिन्होंने क्वेश्चन किया उनको दे रहा हूं, आपको नहीं, because they are younger generation of engineers. This is a positive way of conveying them कि वो अपनी थोड़ी सी इसमें इस्लाह करें, वो भी जरूर अच्छी बात है. Clarity in technical information demands that we should improve our, I mean, English की जो वो capability है उसको बेहतर होना चाहिए. अच्छा जी, इसमें factor of safety देखें. Factor of safety is a very subjective thing. It depends on so many things. When your data set is reliable and the statistical reliability is high, what will happen to the safety factor? बढ़ेगा या कम होगा? कम हो जाएगा ना? ठीक है ना? When your data is less and crude and less reliable, statistically speaking, safety factor has to be higher. अच्छा, when there is a lot of variation in the rock mass at the site, your safety factor has to be higher. When less budget is allocated by the owner of the project, so you will be constrained to carry out less investigations. So उस केस में आपका वो कम हो जाएगा. लेकिन basically अगर आप के जो question है उसको सिर्फ उसको लिया जाए, you are asking vis-a-vis the rock type. When the rock is variable, yes, when it's more variable in strength, then the safety factor needs to be higher than the case of more consistent rock formation, as is the rule for soils, simply because we cannot afford placing some of the foundations in an unconservative condition, that we assign them higher bearing capacity and they are placed by mistake in weaker rocks. ठीक है, उसको remove करने के लिए आप उसमें safety factor को बढ़ा दें, या conversely speaking, safety factors are an interplay. It has a trade-off between with the rock parameters. भी देखिए आपने अगर conservative parameters पहले ही रख लिए हैं, फिर आप safety factor भी बहुत बड़ा कर देते हैं, तो where you are going to end, ठीक है ना? If you have kept parameters which are liberal, somewhat liberal, ठीक है, उसमें आप safety factor थोड़ा सा बढ़ा सकते हैं. So ये बहुत सारी चीजें हैं. इसी वास्ते कहीं भी सेफ्टी फैक्टर के मुतालिक कोई हार्ड एंड फास्ट सिचुएशन कहीं भी डिस्क्राइब नहीं की गई. आई वुडंट से इट इज अ ग्रे एरिया, बट इट इज एन एरिया ऑन व्हिच अ डिबेट कुड बी देयर, एंड it is an area which draws the attention of the engineers on the basis of their experience, and also that engineers with less experience should seek guidance of their seniors while deciding about these parameters in your design office or in your work. खुद ना इस तरह के फैसले करें, क्योंकि आपने पढ़ाई भी अच्छी की होगी, एमएससी पीएचडी भी किया होगा, आपको मैथमेटिक्स कंप्यूटर सॉफ्टवेयर में भी you will be very skillful and having a lot of command, but your engineering intellect that develops with experience. So guidance of seniors is necessary at every stage, even if you are highly qualified. My message to junior engineers, relatively junior engineers as a profession, don't try to practice separately in isolation by opening your small offices right from the beginning without any guidance. Like doctors get guidance, you see, in hospital by their professors and surgeons. So engineers also need to get guidance in their practical work, you see, through senior engineers. तो इस तरह ये चीज समझ आती है. वैसे वो otherwise जो है ना, वो इस तरह खुले का खुला रहता है. There are so many methods and so many. I have my own indexes on the basis of my experience, and I think they are worthwhile. They are of high worth. They are of high value. So similarly, जिस जिसने जहाँ जहाँ experience gain किया है, उसके मुताबिक काफी rules of thumb कह लें या अपनी guidelines होंगी. And this always happens with experience. अच्छा ये देखिए, ये Bowles is a very famous, Joseph E. Bowles is a very famous author of foundation analysis and design. So in the chapter for rocks, he gives a different notions, different ways. He says that find out ultimate bearing capacity for intact rock and bearing capacity factors, not by Terzaghi or Meyerhoff or Hansen, but by Stagg and Zienquist. Intentionally, I have not included their factors. They are, unnecessary information. You can just consult the book if you are interested.
So here,
उससे आप, हाँ जी,
since you have referred Bowles, one
Oh,
question
yes.
has come from some person. Is Galaxy A50. So I can't tell you the name of the person. He has asked, please recommend good books to read. So I think at this point you can recommend some other books also apart from Bowles.
Okay. Don't you find Bowles a good book? It has some mistakes, yes. It has some mistakes. Well, if you are interested in the books on rock, then there are many good books. First of all, you have to brush up your knowledge about the basic properties of rock and basic definitions about various terms. As I've devoted some time in the beginning part of this lecture, unless you understand them properly, you will not be able to decipher the good concepts in rocks and rock mechanics. But you see, there are different, books which are available, and some books have, like Peck, Hansen, and Thorburn, in addition to Bowles, and you see, like Rock Slope Engineering by Hawk and Bray. There's a fairly good book, and there are some other books on the rock mechanics. You have to go into that, and in addition to that, I will recommend to you that being practicing engineers, you have to refer to different codes, study the chapters or sections related to bearing capacities for determination of bearing capacities in rocks, AASHTO, American Society of Civil Engineers, Canadian Code, IBC, like this. So this will give you good exposure. And also you can read
Never standards भी ठीक है.
NAFAC, okay. NAFAC is good, but one flaw in NAFAC is that they don't revise so frequently. So they are old standards, like we have some old physicians, old style doctors, old style engineers. I would say in some areas it is over conservative. I would not say that it is incorrect. Mostly the provisions of NAFAC are valid, but mostly they are quite conservative also in many respects, because they don't revise. Like AASHTO is a very forward moving code. It revises every 3-4 years. American Society of Civil Engineers, and another code which I say, and you should go through and read the relevant parts regarding rock, is the Federal Highway Authority of USA, FHWA, Federal Highway Authority of USA. That's a good code. And some people think, and I'm also one of those, that publications on the topic of American Society of Civil Engineers, PSCE. They are like a very standard, very standard reference. They are very correct. They are edited by large board of experts. उनमें mistake का, error का होना, omission का होना बड़ा मुश्किल है. And to my surprise, they have taken most of the documents of US Corps of Engineers. US Corps of Engineers, they have adopted most of the documents of Corps of Engineers. So that speaks of the very high quality of work done by US Army engineers. तो मैं इस पे मजीद कोई कमेंट नहीं देता, लेकिन जैसे कि हम सारे हैं, सिविलियन हैं या फौजी हैं, हम सारे प्रोफेशनल काम में जरा हमें बेहतर होना चाहिए. Anyway, तो ये बाउल्स का ये पहला तरीका which is listed at number 2, which is aimed at finding bearing capacity using
Sohail, hold on.
Yeah, please.
No, as the question was asked regarding good books, it was
Hmm.
Mr. Mohin Gondal who asked the question, and he asked a supplementary, please recommend good softwares to learn for junior engineers. So I think you answered here at this point.
Well, basically, the use of software I will not recommend. You see, I will not recommend use of software unless you guys have good command over understanding the rock itself. Software will come later. You see, what I've seen is it goes reverse. People start using software without knowing the concepts and the theory, so that is wrong. That is a wrong practice. First of all, brush up yourself. Then there are many softwares. Rockware is some very common kind of software, and you see, you can use GeoStudio also with some limitations, you see, etc., etc. But what Rockware is some good for rock mechanics, and you can use directly numerical modeling like FLAC 2D, FLAC, Itasca. When tunnels are involved and you have to deal with rocks, and Itasca is considered to be quite good. So, okay, 2D, 3D, FLAC, they're very common and good softwares. Plaxis is no bad. It can model for soil as well as for rocks with some limitations. Remember one thing, young engineers, that the importance of selection of representative parameters, it has been very less talked about in geotechnical engineering, in civil engineering, and it is very important. Your answers will directly be dependent on what parameters have been plugged in certain mathematical equations or certain graphical correlations. वो कहाँ से आता है art? That art is thoroughly through experience. इस वास्ते, please get guidance of your seniors, of your true seniors, those who have really worked, not senior by number of years or by age. जिनकी chronological age आपसे ज़्यादा और वो senior है, मैं उनकी बात नहीं कर रहा. Those who have more professional, good professional experience, more than you. अच्छा जी, तो second इसका तरीका वही मैंने अभी पहले बताया, that you calculate the ultimate bearing capacity for the intact rock, like calculated here, and multiply with the square of the rock quality designation. एक और तरीका है, बाउल्स ने ये भी कहा है कि आप ऐसे करके देखें, that calculate the unconfined compression strength and depending on various variables, जैसे मैंने अभी बताया, select a safety factor. And एक और जो चीज़ मैंने नहीं बताई थी safety factor की selection में, importance of the work involved, that dictates the degree of safety that you are keeping. If higher importance and higher degree of safety is warranted, then higher safety factor. ठीक है, ये बड़ी वो क्वालिटेटिव चीज़ है. इसका कोई वो रूल नहीं है कि आपने किस सिचुएशन में, मैं आपको सारे केसेस बता दूं तो वो 1000 सिचुएशन में एक्सप्लेन कर दूं. इट्स नॉट लाइक दैट. ठीक है जी. बाउल्स ये भी कहते हैं, look at him, that when RQT is 0 or close to 0, that is we are talking of very weak and very shattered rock, then we can treat rock as soil and apply the theories of soil mechanics. Then you forget about rock itself. ये मेरा ख्याल है already talked about. अच्छा, ये तो बाउल्स की, ठीक है जी. I agree with the I mean, some feeling of some of you that bowls have some critical mistakes at some places. Not in the context of this rock, but in the context of some other topics. Now, these are the documented methods. One method which is good is Rafil and Goodman method. Rafil plane India is buying, and here we are discussing the Rafil method. So earlier I was talking of the continuous intact, you finding properties of intact. Now it is with the joints and discontinuities. So estimate phi of the rock mass, find unconfined strength, and using this relationship, multiply unconfined with n phi. N phi is defined here in terms of angle of internal friction. So bearing capacity will be higher for a continuous rock mass. ये सब जो तरीके हैं आखिर में मैं आपको बताऊंगा which are given by codes. अभी मैं एक different literature से ले रहा हूँ, फिर codes के तरीके in my personal opinion they are much better. Was the information for engineers comes in the code when it has been tried and tested, you see, by performance. So the codes are the most reliable third degree accuracy source. So Mr. Sowers gives the bearing capacity equation methods for rock. He says you have to first decide whether the spacing between the joints is less than width or more than width. If it is less than width, you have to decide if the joints are open or if they are closed or filled with some material. If they are open, then this formula, like in, you see, open joints, and this closed joints use Bell's approach, Bell's formula, or this formula is called Bishnoi. I have already discussed for widely spaced joints in which the foundation width is less than the spacing between the joints, right? When data is inadequate, as Bowles also says, but here it says that you can take ultimate bearing capacity as equal to unconfined compressive strength. And of course, you have to divide by the factor of safety. Now, out of all of these methods, I'm going to give you this procedure, which in my experience is very good and more representative and more simple. It says it is the Ashtos method. They have given this method for design of foundations of bridges, but I believe that same can be used for design of foundation of structures, of buildings and other works too. The method is based in the form of tables, considers rock jointing, their spacing, rock mass rating, RQT, unconfined compression strength, etc., and just requires multiplication of two variables. This is a very standard method. Let us see what NMS and what C0 are, right? You see, it also considered the classification, rock mass rating. So that's why I intentionally included this topic of classification of rock mass rating in this lecture, so that you are at least familiar and exposed to the classification system, that it is not difficult at all, but it has a relationship in many approaches to the evaluation of the bearing capacity of rock. Now let us see that what is NMS and what is C0. First of all, C0. C0 is nothing but the unconfined compressive strength, right? You have to decide. If you have the test results, good. If you don't have test results, then we can decide out of the given ranges for different rock types. And here, their group descriptions are there, whether they are carbonate or argillaceous or arenaceous or what. So, first kiya, you're falling somewhere here. We're talking of shale, ठीक है जी? This kind of shale. आप इसमें आपके पास test results भी है, and आपने देखा your test data fits in this value, in this range, right? So which rock category this is? This is B. So the purpose of this table is to select on the basis of unconfined compression strength the rock group out of A, B, C, D, E. So you have group B for this. Now go to the next table, which allows you to calculate NMS, variable NMS. NMS will be defined in 5 classes, A, B, C, D, and based on rock mass rating, the NGIQ rating, and RQD, and also general description, right? So you see that we had calculated category B. Now in category B, we have to see, say I have just RQD data. My RQD is, say, here. So my NMS value is 0.056 as per H2. I will multiply this NMS value with the unconfined compressive strength to get the ultimate bearing capacity. Right? This is the way H2 wants to. H2 is a very much recognized code, and they have given these principles. I think this is on the basis of a lot of database and research carried out by them. So आपने देखा ये बाकियों से खासा मुख्तलिफ है. This method is quite different. Quite different. And it's not a bad method. कोई और क्वेश्चन है? थोड़ा सा आगे आपको कुछ तस्वीरें. I'll go you some, give you some pictorial information. I'll show you some pictures of some sites with the rocks and give you a bit description. Is some question, please? Nothing. Okay. So we go ahead. I've listed only some of the projects where I came across rock and some challenging situations are there. One was while dealing with the design of bridges on Karakoram Highway project. Rocks along Karakoram Highway are different from the rocks in other places of the country in that they are mostly igneous, that is, they result from the solidification of molten lava or magma. When it comes out of the ground, it's lava. When it solidifies within the ground, it's magma. And when they are sedimentary rocks and they undergo pressure and heat treatment, and that's called metamorphic action. So there are some metamorphic rocks like hard slates and schists also along KKH. We have basically igneous and metamorphic rock. So we could see that from bearing point of view, generally situations for bridges in particular were variable though, but not very difficult, except the situations where the beds used to be unfavorable in dips and where rock fall or rock toppling situations could be there, which had to be avoided by bolting, by recommending bolting or by shortcreting. At Naluchi Bridge site, there are schists, which is a kind of metamorphic rock, but schist is that kind of metamorphic rock, and where the joints are very close, they are very thin. So what would one expect in thin joint? When you try to core through, you get highly crushed rock. So can you imagine in all the borehole, in all the core holes, there was zero RQD. So what we were to do, now you just think over this. I've told you enough that when RQD is zero, what we have to do. We have a lot of data which can permit us to find the bearing capacity for zero RQD. One is the simple correlation of RQD with the bearing capacity. Other is you go into the jargon of calculating rock mass rating and finding the values. At NUST campus Islamabad, like in Islamabad, we also have, like in Murray and Azad Kashmir area, we call them cephalic rocks, alternate beds of sandstones and shales. Although their grades and their strengths and indurations are different from the rocks in Murray area and in Kashmir area. So at NUST campus, basically there were a combination of these two rocks, folded and faulted at faces at the different depths in different patterns. So virtually, I had to design every foundation of every block separately by individual consideration on the basis of whatever information was available, and we had to treat and improve the rock and to improve the bearing condition before placement of the foundation. So similarly, I'll show you some pictures of this study of G11-4 rocks there in Murray. Sometimes there are thick beds of shales, so they govern the design of rocks, and sometimes the shales are very weak and very wet. Like in Murray, there are drainage issues and heavy rainfall too. So when they're too weak, then they have to be taken as soil, and sometimes the shales of Murray are even poorer than, they are worse than soils. अभी मैंने शुरू में comment दिया था ना कि mostly rocks are, worse rocks are better than the good soils or equal to the good soil. This is not always true. Mostly that is true. So we encountered rocks in Islamabad that ComSets also then, or M9 motorway structure, I remember, during the earlier design stage studies of M9 motorway, which is to link Hyderabad with Karachi. Very weak shales are present. Like मुझे मरी की shales याद आ गई. They are very weak and very much jointed, just like soil. N70 bridges, N70 highway runs in Balochistan. So we had limestone, schists, sandstones, shales, and different varieties of rocks you see there. So we have to deal with them accordingly. Here you see a picture along Karakoram. This is along Karakoram Highway. So you can see the beds exposed as some shearing along the bedding plane having taken place, and these beds have been toppled because of joints. There are some joints here that separation of the blocks because of the joints has taken place. That is called toppling. इसके जो बेड्स हैं आपने देखा एक बेड्स का प्लेन ये है और ये जॉइंट्स के प्लेन इधर है. सो इसकी ट्रीटमेंट अगर करनी हो, अगर कुछ यहाँ बनाना होगा, देन दे विल हैव टू बी हेल्ड बैक. वैसे आप नहीं कर सकती. सो this is badly shattered and folded, tectonically disturbed area along KKH, rockfall area. What one would do here to improve the ground, you see, you have to use.
Here for a second, we have two questions.
Yeah, please.
The first question is from Muhammad Asif. He's asking, can we adopt factor of safety as less than 1.5 in good conditions? Question number one. And question number two is, if there is a cavity identified under foundation, will we refill that with grout, or we will excavate and refill that with recommended material?
Well, when you have very good rock and you have a lot of testing data, you have a lot of data of investigations, and there is very little variation in the strength of the rock, then there is a possibility and that for less important works, we can keep the safety factor of at least 1.5. I will not go even myself for to 1.5. I'll use a higher value always for rocks, because I know there are inherent weaknesses which are not discovered or revealed properly by the limited investigation in short time to be done. In Pakistan now, there is another trend, which is the fast track projects, which has further squeezed the time of investigation and studies for engineers. So I will strongly advise you not to jeopardize, you see, the designs by reducing the safety factors when you have inadequate data, and mostly you will have in your carriers inadequate data and less reliable data because of the faulty geotechnical investigation work, etc., etc. Sometimes the joints are induced or cracks are induced by faulty operation of the rig. People don't, anchor the rigs properly. They have vibrational eccentric effects in the rotary action of the coring operation that induces artificial cracks or joints, which are taken as the natural joints, you see. So such things go hodgepodge. So this is the answer to the first question. And can you repeat the second question?
Second question. second question is, if there is a cavity identified under the foundation, will we refill that with grout, or will we excavate and refill that with recommended material? And then now a third question has also come.
Let that be after this. You see, there are several ways of dealing with a cavity. If there's a big cavity and the structural load is going to be heavy and important, I avoid that site. Now, this recommendation is very much conditional. It is not a generic recommendation. When I've told you to avoid the site, it has some conditional parameters with it, right? When the cavity is very big and when the loads are very high and the safety concerns are very high, ठीक है जी, तो आप उसमें avoid करें तो बेहतर है, बजाय के पहाड़ दे या grout material का भर दें. Second is, yes, you must replace the weaker material or the cavity if that is void with grout for ordinary purposes. That works well. I would further say that one can alter the foundation type there. Go a bit deeper or use a deeper foundation system to bypass that weaker area of cavity, right? So that will resolve the situation in a better way, because we don't want any foundation of a structure to move or to, get displaced or undergo more deformations, right? So this is the answer to the second question, and I'm waiting for the third question now, Taisa.
What are the major causes of settlement and remedial measures?
Unfortunately, this lecture is not on the settlement of rocks, right? So I would not like to comment deliberately on the answer. But okay, for your satisfaction, I can answer you very briefly that in rocks, the settlements because of compression, if the compression was the governing factor in the settlement, then that would be really low, okay? Because the rocks are indurated tough materials. But unfortunately, rocks have beds, joints, faults, fissures, shear planes. So in many cases, movements do occur, not because of compression, but because of movement along these discontinuities. Now, this movement, when this occurs, you see, it could be any value if proper measures are not taken. But generally speaking, like we are more worried regarding settlement in soil, we are less worried in normal situations about settlement in rock, because we know that in most design situations, automatically the settlements will be generally less than half an inch. That is documented in many codes. But if the movements along beds, along joints are to be there, then the settlements could be any value, or movement could be any value. Gee, any other question? Nothing. So I proceed ahead. So here you see simply rockfall. I think you understand the difference between rockfall and rock topple. Here I use the word topple. When there is a fall, you see, and when the particles fall a bit away, you see, that is toppling. They turn during fall, they turn around and then fall. But when there is a straight fall under gravity, that is a falling, resulting into residual deposits. Just showing you a glimpse of some log nust campus under a cover of 5 meters of lean clay and sandy silty clay. You can see here sandstone started, soft fragmented, shaly material. So that kind of logs were there, and coring into rock was also done. And there were surface exposures of sandstone and shale rock formation in different variety. And soils were also there. So different color bands give information about different material types, rocks and soils exposed at the Nust campus site. And these have been plotted on the base topo survey map to result into these geological informations. And they have been simplified by this method. dividing them into simply two zones. Zone 1 is rock of shale type, and zone 2 is the other type, which is a cohesive material. So rocks are in principle in the purple zone. The structures which are falling in purple zone, they had basic issues of rocks at the Nust campus site. Here you see Gomrid Employees Housing Society Sector G11. Under a
Well, we
thin
have a
cover half a
question.
meter. Yeah, please.
This question is being asked by Mohsen Gondal, and he's asking, is there any dynamic analysis included in your lecture for a railway line, for a railway line BC analysis in Quetta Taftan region? Is there any dynamic analysis of rocks? Why I have to check why should do or include in our study?
Well, you see, vibrations are important. They result into deformations. Yes, that is, and one can prepare a dynamic model, and where the things are important, the project is important. Some representative dynamic parameters should be plugged in the relevant analysis in the SAP model, the structural model, or some other model like Plexus model, in some numerical model, to find out the extent of deformations, because deformation will become important. Unfortunately, my lecture does not include dynamics, you see, because it's a limited time lecture. I cannot include each and everything. I've already tried to squeeze, you see, a lot of information, and some of you might be definitely getting bored because of inclusion of a lot of mathematics, which I try to keep to the minimum. So here you see presence of shales with intercalation of silt. So here in this G52 Comsets building in Islamabad, you can see coring run. You can see every run is about 1 meter long. Yeah, 3 to 4 meters is one run number 1, 4 to 5 is run number 2. So coring is done in several runs. इसको run कहते हैं, एक जो उसका है ना, एक cycle, एक stage, that is one run. Now here the core recovery is 76%, 24% नहीं आई, 76% आई, but the RQT is 64% and shown graphically also. आपने देखा? So RQT is not bad, except it starts dropping at below 7 meters, then becomes 14 here. Must be weak part of the weak zone. There are weak zones in the same rock, and there are hard zones in the same rock. So that is because of the formation. That is because of the formation. ये मेरा ख्याल इतना clear नहीं है इसको. Oh, this is for your information and for your curiosity, a picture taken by me at a rest house in Miyawali. Thank you very much. This is the end of the lecture, and now I would welcome some questions, more questions, although many questions have been asked. Please come out, speak out if you have some other things in your mind. It's a very intriguing, very detailed, very complex topic. And I know, perhaps despite my best effort, matter of 2 hours is less time and one cannot do justice. You see, एक दिन के कोर्स में भी नहीं होता ये, पूरा एक बार आपको पढ़ाना पड़ेगा, पूरा कोर्स एक लंबा, एक चीज. So I have tried to touch so many things to open your VN so that you can make self-reading. At least in my experience, I have seen that when one is exposed to one small concept or to some idea, one can then visualize. One can then, with the help of literature, can make self-study and go further ahead. So that was the purpose, to give you training on this, that when rocks are there, you must not just raise your hands and say, we are hands up, now what to do. Now I think you have some enough gunpowder to take some decisions yourself and get the guidance of your seniors. Hello. There is a crosstalk.
we have a question from Sohail. Can you listen to me? Sohail, just hang on. Just hang on, please. Just hang on. Sohail, can you open up your mic, please?
Oh yes, sure. I've done
Okay,
it.
thank you. Thank you. Now
No
I
problem.
have a question from Mohin. He's asking if there is a water seepage along sliding plane and it is continuous and it cannot be avoided, will we work there?
Yeah, if it cannot be avoided, and if the site is such that it also cannot be avoided as a matter of compulsion, we have to build there. So we can take care of water seepage. I have been doing it at many sites in our mountainous areas before launching the projects. One can very effectively in rocks provide horizontal wick drains. You make a hole of sufficient depth, like 10 to 15 meters in the rock, and then take perforated pipe, like one can think of having a PVC pipe with perforations of slot sizes, appropriate small sizes slot, and then you can also wrap a geotextile with the anticipation that the flowing water may bring sometimes from the joints, or if the rock is weak and shattered some small particles, with the anticipation that the particles should not enter the pipe. You just insert that perforated pipe wrapped with geotextile into the hole, and you can make a series of holes in the form of a network in the whole rock mass, in the whole rock face. So that works very effectively, provided there is a way of draining out the water and collecting the drained water properly in some big drain and then draining it away, disposing the water away that drains the rocks. Draining the rock is a good practice that improves the strength, shearing resistance along the beds and along the joints too. Yes, please.
There's another question from Mr. Furqan Hamid. He's asking, will dimple sheet work? I am not sure what does he mean by dimple. What does that mean? Can you understand, Sohail? He's asking, will dimple sheet work?
Dimple sheet, I know
I'm
the
not sure.
dimple on the face, but not a dimple sheet. I'm not aware.
Even I don't know about this sheet. Maybe it's a new technology. So
What
he's
does it
asking.
say?
He's
Yeah,
asking. He's saying this is a geotextile sheet, sir. Maybe
it's a could be a
it's a
brand. Yeah, could be a brand. There are many
name.
brands. What it is to be used for? What is he asking?
He's just asking, will dimple sheet work?
For what?
He didn't ask anything. Just
Okay. So his question is ambiguous. So there is no way to reply to this unless he clarifies what is he asking. I think he has used a brand name of a sheet, and sheet is to be used for what?
now. Now, there's another question. I don't know who is this Galaxy A50. Maybe Mr. Mohin, I think. Sir, please, if you can give next lecture on BC of shallow and deep foundations on soils. Well, this is something to do with Pakistan Society of Civil Engineering Engineers Administration. We have noted your proposal and we will put it to the persons in charge for the lectures and get back. And we will try to have a lecture on this topic. If Mr. Suhail is ready to give lecture on this topic, for sure we will try to put him in our tight schedule somewhere, but it is not a promise. We have noted your proposal. Then again, Furqan Sahab has asking a question: water travels through the dimples of the sheet from source to drain pit. So this is a comment or is it a question? I really don't know. Water travels through the dimples of sheet from source to drain pit. Can you figure out what he's asking,
No,
Suhail?
no, I'm not being able to figure out. I'll rather like to comment on your on the previous comment given by someone regarding another lecture from me covering the areas of design of shallow, geotechnical design of shallow and deep foundations. Please note that I've already given a lecture. I've delivered a lecture on shallow foundations. That itself is a vast topic. So yes, the deep foundations can be dealt with separately in a lecture. And if required by Pakistan Society of Civil Engineers, I can deliver again the lecture on shallow foundations.
Yeah, Suhail, thank you very much for your kind offer. But as you know, the lectures are planned every year in the first
Okay.
month of every year. So we have already given the list of the lectures to Pakistan Engineering Council. We have to strictly follow that schedule. But if we can just make this lecture sandwich somewhere between the two lectures, that we will try. If it is possible, then I will let you know. Okay.
Okay. I am available. Tahir Sahab, I am available as a passionate lecturer. I don't have any problem.
Yes, yes. Pakistan Civil Engineer Society owes all your services. You are a founder member. So,
Thank you.
Acha ji, now what is this? We have a lot of queries as we are facing problems. So now again Furqan is asking that I am telling it's used in tunnels to avoid water, and we use such sheet in sliding planes. He's again talking about that dimple sheet, and he's asking that it is used. He's telling us it is used in the tunnels to avoid water, and then he's asking, can we use such sheet in sliding planes?
I'm asking him, what is the technology and what is the fun of inserting this sheet in the sliding plane? How come this is going to be possible? This is not a possible technology the way you want it to use for the purpose of preventing seepage. I have told you the standard method of reducing seepage in the rocks by making horizontal uh, drains, horizontal wicks. That is the best way of reducing seepage. And also, we can control seepage on the surface of the rock by making longitudinal drains which can have some catchment and which can collect runoff and may dispose the water away from the area of the slope where structure or works have to be constructed.
Uh, okay. Okay, Mohsen Gondal Saab, thank you very much for getting yourself identified. Mohsen, so I don't think you got yourself registered for this lecture. So if there is any issue with your certificate, please contact Miss Sadia. Now people are asking, kindly share the lecture via registered emails. Well, through the file of the lecture would be too big. This lecture is would be upload. All our lectures are uploaded on a Facebook page of Pakistan Society of Engineers.
Yes, yes.
Or now it is we also upload it on our YouTube channel on YouTube. Yeah. So the link to both of the social media channels are given on our website. You just go on the website and find out the link, which is normally at the right top corner. Both links. So you can use either of the link and then download the lecture from there. Otherwise, for us to send the mail, attach this lecture in the mail would not be possible. Thank you. So I think thank you very much. Very informative. I wanted to have it for one more. Okay. So Any more questions? As we are already past our time by 15 minutes. So if there are any more questions, kindly ask. I will give you another, let's say, 5 minutes. It looks,
In
yeah,
the
yeah.
meantime, I would like to ask a question which any of the participants may like to answer. I see a number of young and full of energy faces of the participants. Which of you have used some methods to calculate the bearing capacity of foundation for foundation in rock when placed in rock? What kind of methods have you used? Have you ever been confronted with the situation of placing foundations on rocks, and then what you have done? Anybody could like to explain or deliberate on that?
I think the most pertinent question would have been that how many of them are geotechnical engineers? Only then they would have used calculations for the bearing capacity, you know.
But I know that many civil engineers, although they are not geotechnical engineers, they understand to some extent
Normally,
the
civil
behavior of rocks. Yeah.
Furkan is saying he is using SPT data. But
SPT
how
is
he,
not a test. SPT is not a test for rocks. So
yes,
it is
that,
irrelevant.
that
Irrelevant.
I mean, I was a bit surprised by how he is using SPT data. By crush, and now Rana Ibrahim is saying by crushing a core sample in testing machine.
By crushing a core sample in testing machine, yeah, what is your query? I'm not understanding your query.
That would give the crushing strength of the rock. That is the compression test. So
Yeah, that will give the unconfined compressive strength. And my lecture has revolved a lot on the calculation of unconfined compressive strength and its use for finding bearing capacity.
anyhow, Vivo कौन था? I don't know. नाम नहीं. Furkan sir. I said I used SPT some years ago. So Furkan sahab, SPT, so some years ago it was standard penetration test. Even today it is a it is the standard penetration test, and it is normally used in the soil, not on the
Soil.
rock.
It is for soil, not
Yeah.
for rock.
So let's see. Let's conclude it here, Sohail. Thank you
Okay.
very much for such an informative lecture, and I hope that our young engineers must have learned a lot from this lecture. It was really a very lecture given in a very simplified manner, making the things very easy for you. And being an experienced engineer, even I learned something new today. So, and I would like all the engineers who participated today that Ms. Sadia has already sent you a pro forma. Please give us the feedback. This is not only for you. The feedback will give us to improve the quality of our lectures and the quality of the transmission and the quality of the content of the lecture, the type of the lecture. So kindly don't forget to send us your feedback. Uh, Thank you very much for participating. And there are a few announcements again. First is, as I had told in the beginning, that this office is going to change to a new location that will be informed to you by Miss Sadia. It is a little far from Lahore, so not very far. It is within the suburbs of Lahore, maybe not very convenient for everyone to reach there. So for that matter, we have uh, uh, we have an alternate office which is Rizwan Consulting Engineers, 83M Model Town Extension, Lahore. So those of you who can manage to get your certificate by 20th of this month, still you can use the existing office. From here, Miss Sadia or Ahmed would be here for the distribution of the certificates by 20th August. And those who will come after 20th August, they can go to Rizwan Consulting Engineers, 83M Model Town Extension, Lahore. From there, you can get your certificates after 20th. All these details will be sent to you by email by Miss Sadia Naveed. And the timings of that office are also same. That is 10 to 4, 10 a.m. to 4 p.m., Monday through Friday. So gentlemen, the next lecture we have on 12th of September 2020. It will be delivered by Dr. Ali Rizwan, Dr. Professor Ali Rizwan, again, a very famous geotechnical civil engineer. And his topic would be on-site health assessment of structure-related issues. On-site health assessment of structure-related issues, 12 September 2020, same time, Dr. Ali Rizwan. He would be there. And in the end, again, the same request that please propagate about this society to your people. Today, mashallah, we have got some improvement in our associate members. Tally, we are standing at 151 to date. Student associates are still 13 for the last 3-4 months. Our magazines are 8 August 2020. Print has been uploaded on our website. Newsletters are 9. There we are lacking a bit. And but please help us in propagating about Pakistan Society of Civil Engineers. Let your friends know about this society. They should join this society. And this society is, I think, doing a good job for the young engineers, for educating them and bringing them the lectures. We want to start new activities. So people should join us, join our committees, and only then we can move forward. So El Kibriya, thank you very much again. I'm really thankful to you and to all the participants, especially our professor Mia Ziauddin Sahib. He has been very regular participant to this webinar. And incidentally, maybe a lot of young engineers don't know, Mia Ziauddin was a professor in UET. He is the chairman of the Pakistan Society of Civil Engineers. And I am the CEO, he is the chairman, and he's giving us all his advice to us in all fields. And we thank you him for all his efforts he's doing to make this society successful. So thank you very much, Ji, and see you on 12th.
Tahir, one minute. Sorry for the interruption.
Yeah.
I just want to take 1 minute in the end.
Please.
I know Mia Saab is there, and Ziauddin Mia Saab, very much honored and very much privileged to see him here. We have been, throughout our 4 or 5 years stay at UET, we have been listening to his illuminating lectures, and he has been our very, very good, very fine teacher. We learned the skills of design of reinforced concrete, and he's still on our heads, and we are very lucky. And may Allah give Mia Saab long life with good health. Sir, thank you very much.
Very nice of you to say such kind words about our professor. And Alhamdulillah, he's in good health, and we all pray that he has good health in the future also. Thank you very much, gentlemen. See you on 12 September 2020.
Allah Hafiz.